Hey everybody, this is Austin and welcome back to my channel. In the last video we machined the neck for this guitar, but it's desperately missing something. We need a fretboard to go with it. So that is the plan for today. So we're going to start by machining some copper that we can use as fret markers, and then we will plane down our raw fretboard stock to a correct thickness on the CNC, and then finally we will machine the fretboard and glue in the inlays. Now, I realize that I have not created a cam for fretboards video yet, so those of you who would really like to see that, don't worry, I will get to it, I promise. But you'll at least get to see my process and join me in turning only a couple dollars worth of copper and a beautiful piece of wenge into what I believe is going to be the showstopper of this build, the fretboard. Let's dig right in. All right, so here's the material I'm going to be using for the inlays. It's a 1mm copper plate, and it's got a film on it that I can peel back, like so. I filed the corners a little bit, and that's what we're going to be using. And the film doesn't really matter. What I'm going to be doing is I'm going to be using the blue tape method, gluing it down to my wasteboard, and I've generated a little pattern that I'm going to use to go ahead and cut those. So let's go ahead and do the tool pass for those. We need to cut these first, so that way I have them ready to install once the fretboard's a little partial the way through. Okay, so here's the plan. I've created a really basic sketch with a basic stock of my copper. And I didn't extrude any of the little inlays or anything. I'm just going to use the sketch to generate the tool paths on this stock. So I'm going to go ahead and use a tracing operation. So 2D trace. And then I'm just going to come over and let's select our 1/8 inch end mill. Sorry, I had that on the other screen there. We're going to use our 1/8 inch end mill. And I'm going to do 16,000 RPM. And we're going to do a cutting feed rate of 40 inches per minute. That should be fine. That'll leave us about 1 1/4 thou feed per tooth, which should be okay. We are cutting metal here, so I need to be pretty conservative with my feeds and speeds and my chip loads. So I'm okay with the way that is. So let's go ahead and do geometry. And in this case, I'm just going to select all of these major construction lines. I'm not going to select the little ones in between. And we'll just select those. And then our heights, we don't really need to specify that. It's just going to, on tracing toolpaths, it expects that you're basically going to be using like a V-bit. But what we're going to do is we're going to use multiple depths with a axial offset, which will allow us to cut down into the stock further using this. So then I'm just going to do passes. And first things first is we're going to set an axial offset. So this is actually going to be how deep into this stock are we going to cut. So we're going to set a negative value of negative 1.1 millimeter. So my stock is 1 millimeter, and I'm going to go 0.1 millimeter below that to ensure that I cut all the way through. I don't want to have to file or sand or grind anything like an onion skin away. And then we're going to do multiple depths. And in this case, I'm going to go basically like a 3D printer. I'm going to go in 0.2 millimeter layers. So 0.2 millimeter. And we're going to say a number of step downs. So since this is 1 millimeter, that would be 5 step downs. And that should be good. Let's go ahead and check it real quick. I didn't turn off coolant, so let's turn that off real quick and hit OK. And let's simulate this really quickly. So slow this down. Okay. So it's going to cut the perimeter in 0.2 millimeter increments, and then it's going to start slicing its way through. Looks like it's doing it in a little bit of an awkward order, but that's okay. Doesn't matter. Okay, let's speed this up. Make sure we go all the way through. Okay, that looks good to me. And I'm not worried about these parts breaking free because I'm going to use the blue tape and super glue trick. I'm going to make sure the whole thing is really slathered on there, so that way we'll have a nice adhesion on there, and then I can just peel off the tape when we're done. So that should be okay. So let's go ahead and hit close, and let's right click and say post process. And I'm going to call this copper inlay. And it looks like it reset my output folder for some reason. So I'm going to change that to my Dropbox. So I use a Dropbox folder so that way I can send things to my laptop. I'm doing this on my desktop right now. And so I'm going to go Fusion 360 Post Process, Guitar, and let's do, actually, go back, Guitar, and hit OK. And I've got my machine set as Xcarve, so it'll automatically grab the post processor for me. Let's go ahead and post that. No post processor selected. Okay, and let's do Xcarve, or Inventables. There we go. Xcarve by Inventables. Select, post, and we're going to put this in Guitar. Yep, copper inlay. Got it. Okay. Now I'll see you guys over at the CNC, and we'll go ahead and cut this. Okay, so I'm going to lay down a couple strips of tape, doing my best to get them as lined up as possible. I'm just going to cut it right on the front board here. So we're going to do right there, like so. And we'll do another one. And I'm going to try to not overlap these so I don't introduce any error. So we'll just try to get those lined up as best we can. Like so. That should be good. Okay, I'm going to do one more. I don't even need them this much, but I'm just going to do it anyway. There we go. Okay. So that's going to be our foundation that we're going to be putting the copper inlays on. And I think I'm going to go ahead and peel one side of this. So like so. We'll leave the other side on top. And we're going to place it roughly right there. So let's go ahead and do that. That should be good. Okay. Let me grab my super glue. Okay, and we're going to place it over top of this main section right here. Looks like I need to unclog this hole. It's dried up a little bit on me. I'll be right back. Okay, so we're going to go ahead and put some super glue right here, like so. And I'm going to make sure that's really nice and slathered around there so I get the whole surface area. Okay. Let's wipe that off. And I'm just going to spray or tape the other side of this real quick. Okay, and then what I'm going to do is I'm just going to spray on here, like so. Okay, and we're going to, I'm going to spray, shake this up a little bit. I don't think I got much on there. There we go. Okay. And then we're going to set this down roughly parallel to my boards here. It doesn't have to be perfect because we have a little bit of an offset, and I'm just going to press it down, give it just probably 15-20 seconds or so, and that should hold it down for me. Okay, so let me go ahead and upload the new program. We have all of our zeros set. I'm going to go ahead and start the spindle, and we're going to run this at 16,000 RPM, and if I need to speed it up, we totally can. So I'm going to go ahead and turn this on. Okay, I'm going to listen to the sound of this. That seems to be a happy medium right there. I might speed it up just a little bit. we're gonna do is I've got a sheet of 320 sandpaper on my tramming plate, which is just a sheet of glass. And we're just gonna sand these real lightly to remove some of those burrs and clean up that surface, which will also help scuff the copper. So that way we have some kind of surface for the epoxy that I'm gonna use, or super glue, to grip to. And then I can just kind of clean up these edges just real lightly. Copper sands super easily, so I'm not worried about that at all, about getting it nice and square or anything like that. Just clean them up a little bit. So here, let's see, we have one right here that's got quite a little bit of film on it, so let's do that one. We'll just scuff that real quick. That's already peeling off. Do the other side. Yeah, there we go. Okay, and we'll do the edges. Just very gently. Try to keep it 90 if I can. Okay, so as you can see, oh, we need to do a little bit more on that one. Not much, just a little bit. There we go. Yeah, I'm sanding the whole surface now, so that's good. Okay, so I don't know if this is gonna come out on camera or not, but you can see we've just got like a lightly brushed finish on there. That's all I'm aiming for. It only took, 30 seconds per. I've got 20 of these to do, so I will see you guys back in a minute. All right, so we've got these scuffed up and ready for epoxy, so now we can just go ahead and move on to cutting the fretboard. Okay, so here's the fretboard material. It's wenge. It's a really nice dark piece with a lot of figure in it. I don't know how well that's coming off on camera. Let me see if I can zoom in here so you can see it a little better. Really beautiful figuring on it. So I really think this is going to make a sick fretboard. One downside though is right now it has both a bow and a twist in it. So I need to actually flatten this material out so that way I can cut the fretboard. Now thankfully I knew this ahead of time and I went ahead and bought a nice thick piece. So it's a 1/2 inch thick piece of wenge material, and you can see I've both got a cup and if I twist it this way, I've got a little bit of a twist in there. So I'm gonna show you guys my surfacing process, which basically what I do is I clamp it up to a straight edge. So let's say I clamp it to this fixture and I squeeze it this way. And what I'll do is I'll grab like a little block right here. Let me bring that over. I'll grab a block like that and I'll clamp in from this direction and just hold it there. And then that way I can just cut it flat. Now I'm not trying to push it down or anything. I'm treating this like a joint. I'm treating my router like a jointer, right? I don't want to push down on it. I just want to squeeze it from the side however it currently is, establish one flat surface, then flip it over and make sure that is pressed down onto the CNC, clamped up, and then I can go ahead and cut the second surface. So that way I get two parallel surfaces to each other. And the thickness that I'm aiming for is I'm going to reduce this down to about 0.27 inches. So I'm going to go 20 thou above my limit, so that way I don't have to do any facing operations once it's on here. And what we're going to end up doing is I'm actually just going to, since I've got the fixture here, I'm going to go ahead and continue to use my work offset that I did for the neck. And I'm just going to tape it in right in place where it would be. And one cool thing about that, and this is kind of a tool and die machinist trick, is if you know that your CNC has some areas that dip a little bit. I know, for example, that my CNC tends to drift downward just slightly the further back I go on the CNC. And so what's really nice is by cutting this in the exact same spot on the CNC and including the same fixture, I give myself the best chance possible to get a fretboard that is accurate to the piece that it was cut, to the neck that it belongs to, let's say. And so if I cut it right here, then I know, and I use the same work offsets I did on my neck, then I give myself the best chance for success. So let's go ahead and do that. Okay, so let's tighten these up. There we go. Okay, and then apply some clamp pressure. You don't need a ton here. I'm just trying to keep it nice and secure. That should be good. Okay, so what I'm going to do is I'm going to measure this. This is 24 inches by 3 inches. So instead of going through the process in CAM of coming up with a tool path and a stock and everything like that for a facing operation, I'm just going to write a very simple G-code file where I'm going to zero off my work offset here and off this surface, and then I'll just go like, 25 inches that way, half an inch over, 25 inches back, half an inch over, and repeating until I get across the entire surface. And then all I have to do then is just lower my Z, and then lower my Z the depth that I want to take the next cut on, re-zero my Z, and then run the same program over and over until I get exactly the thickness I want. So let me go ahead and do that, and I'll be right back. Okay, so I'm going to write a very custom, very simple G-code file to do a facing operation here. So that way I don't have to go model anything I don't already have in Fusion. So what I'm going to do is I'm going to start with G91 incremental. And basically what that means is I'm not going to reference any of my home positions on my CNC. So I will still set my X, Y, 0, but the program won't actually use those. It's just going to move in the direction that I tell it. And the point of this is if I use G90, let's say, and I start from my home position, what I did was if I sent it to Y25 and then let's say I move over X.1 and then I go Y back to 0. Well, the next time I do this, I have to move to X.2. And then each time I'd go like Y25, X.3, Y0. And the problem with that is I can't really copy and paste that without having to go back and edit every one of those X values. So instead, I just want all of my X values to be 0.1. So I'm going to move over 0.1 inches every time I reach the destination that I'm looking for. So what we're going to do is we're going to do G91 incremental, and we're going to go Y25 from wherever I tell it to start. And we're going to do that in a feed rate of 80 inches per minute. And then we're going to do X.1. And now, instead of going to Y0, I'm just going to go Y negative 25. So effectively what we're doing is we're moving it up in Y by 25 inches, to the right by X.1, and then we're going backwards by another 25 inches. And so then I can say X.1 again. And so that means I've moved 0.2 inches in. So let's do this again real quick, and that way we can develop our pattern that we can just copy and paste. So I'm going to go Y25, X.1, Y negative 25, X.1. And so this is a repeating pattern here that I can copy and paste until I reach the width of my fretboard that I want. So we've moved 0.2, and here we've moved up to 0.4. So every time I paste this, I'm going to move another 0.2 inches. So now we're at 0.6, 0.8, 0.1, or not 0.1, 1 inch. And now I can go 1.2, 1.4, 1.6, 1.8, 2 inches. And now I can do it again and go 2.2, 2.4, 2.6, 2.8, 3 inches. So I established a repeating pattern of traveling up Y by 25 inches, over by 0.1, and back by 25 inches and over 0.1 until I reach 3 inches wide. And so that will work for me. So let's just go ahead and save this. So I'm just going to hit save. And let's save it to our post-processor file. And we're going to name this fretboard facing.nc. And that way it'll make it an NC file. And go ahead and hit save. And now we can go over to our CNC and run it. So let's do that. Okay, so I'm going to go ahead and move my Z down. Alright, let's travel down. And I'm going to zero it on this inside face here and just run it right there. And I might move it in just a hair so that way we make sure we cover the entire thing. So let's go over. And I'm just going to touch off like I always do. So let's go in smaller increments now. Okay, we're almost there. Let me just see if we can feel it scrubbing. I'm not going to use a flashlight in this time. Just going to go until I feel it scrubbing. I don't need to be accurate here. Okay, there we go. We are perfectly scrubbing it, so that's good. So that's going to be our X0 for now. And let's go ahead and jog this out. There we go. And then I'm going to zero it to, let's just move it within an inch of our machine here. So right there. And we'll make that Y0. Okay. And now I'm just going to zero my Z to the top of the fretboard. And then all I have to do then is just come back, move my Z down to the depth I want, and then run the program. So I'm going to send my Z up a little bit, move it in, and let's go ahead and zero this. So let's go. Okay, we're almost there. Just going to go until I feel it scrub. I'm just going in 1 thou increments here. There we go. Okay, it's just starting to scrub. So that is going to be my Z0 just for now as a reference point. And then let's go ahead and move it Z up, move it back a little bit, get it out of the way. And then what we're going to do is we're going to send this to Z negative 0.0625. So I'm just going to go ahead and take a 1/16 of an inch off the top of this, and we'll see if we get nice and flat. What I'm going to do is I'm going to turn on my spindle, send my Z down to Z0, and then run the program. So we're going to go ahead and do that. So turn on my spindle. Send it to Z0. Okay, I just realized why it's moving so quickly, and that's because in my code I forgot to type G1, so it's doing a full G0 rapid right now, which is why it seems so insanely fast. So we're gonna go back to F80, but we're going to make it a G1 move command. That way we don't get those insane speeds, and this is far more controlled. So let's go ahead and cut, because right now we're cutting in a full G0 rapid, which isn't good. So let's go to Z0, we're already there. So let's move that up to a safe height. Actually, no, let's go back to Z0. We're gonna set another 0.0625. So Z negative 0.0625. And we're gonna set that as our new Z0. We're gonna jog it up to our safe height. Go back to X0, Y0. Much better. That's more the speed I was looking for. Okay, so our target is 0.27, and we are currently sitting at 0.289. I'm just going to double check that again. 0.2885. So basically, yeah, 0.289. So that means we're 19 thou above our target, which means I'm just going to take about 15 thou more out. I don't want to go below 0.27, but it's okay if it's a little bit higher. So we're gonna take 15 thou out of the top of this, and then we're gonna be done. And then we can move on to actually gluing it onto our fixture, and then go ahead and start cutting it. So we should be somewhere in the neighborhood of 0.27, maybe a little bit over. Okay, just cleaning up a little bit, make sure we don't get any error in our measurement. So we're gonna check this, and I will check this properly once we take it off. 0.275, let me try that again. 0.273. 0.273. Yeah, basically we're within 3 thou or so of 0.27, so I am totally happy with that. So let's go ahead and let's take this off, and let's go ahead and set up to cut the fretboard. So we're gonna do just like that. So I'm gonna clean off my fixture real quick. Grab some paper towels. I'm just going to use a little bit of alcohol just to make sure everything is nice and clean, and so that the tape can stick to it really well. Make sure there's no leftover tape residue or anything from previous operations. Okay, that's looking pretty good. So let's grab our tape. Let's taper down. So we're gonna go right down the center here, like so. I'm just gonna tape all the way down. There we go. Okay. And let's avoid our problems from the last video, where we put the wrong orientation down. So we're going to tape on this side and cut on this side. So let's go ahead and do that. Right down the middle, like so. Okay. Now I'm going to burnish this a little bit, just to make sure that we don't kick it off for any reason. Do this as well. I should have done this on the neck, but I had the dowel pins holding it in. So you know what? On that note, let's remove the dowel pins, make sure we don't end up accidentally running into it. I think I can just leave those ones in. They're pretty far away, so I'm fine with that. I'm gonna choke up on this tool quite a bit because I want as much rigidity in this tool as possible. These are really tiny, I mean really tiny, fragile little end mills. It's kind of hard to focus on the camera. But what I'm gonna do is I'm gonna make sure to put the end mill in as far as I can safely, and still giving myself clearance. So that way I give myself the best chance of not breaking these. So let's go in. There we go. Okay, and let's go ahead and tighten her up. Okay, that should be good. Plenty strong enough. Don't need to crank down on these little tools. And in fact, if you crank down too much, you might introduce inaccuracy. op 1 on the fretboard is done. So we were able to cut the inlay slots with that tiny 1mm end mill. I was so worried about breaking that end mill, and I just must have nailed my feeds and speeds because it cut like butter. It just went right through the wood, no problem, no tear out really or anything, and the sound of the machine was great, so I loved the way that cut. Then I switched over to the roughing pass, and I went ahead and roughed all of that out. Now, in the cam, what I thought I was going to do was install the inlays first and then do that, and in hindsight, I was right, and I should have done that. What I ended up doing after exporting those tool paths was going ahead and doing the roughing pass first, so that way I could just have maybe a tiny little bit of stick out on the inlays and just clean that up in the finishing pass that we're about to do. Well, that turned out to be a bad choice because my inlays now stick out more than 1/8 of an inch, and that means I'm going to have to either come cut each one individually like a really tiny little tool path, or I'm just going to need to wait to do these until the end. But if I do that, then it's going to take a while to sand them down flush, and I'd like my machine to be able to do it for me. So I kind of have to make a choice here. Do I want to maybe file those inlays down to a smaller size, maybe get my DA sander or something and grind them down? Do I want to risk it, install the inlays, and then use my CNC to cut them, even though they're kind of sticking out of the slot and it's going to chatter a lot? Or do I want to just finish the rest of the fretboard, install the inlays, and then file and sand them down afterwards when they're glued in? I'm not sure. right, well there you have it. We have a finished fretboard that is ready to be glued up to the neck. And man, I could not be happier with the way this turned out, both in the way the copper just kind of bounces off of the fretboard, but also in the figure, because originally I intended to use one of the front faces for the front side of this. But as I machined that down, when I was facing it, I actually realized there was a lot more figure hidden in the middle of the wood, and that's what you ended up seeing here. So I am just thrilled with the way this turned out. And I actually got a little lucky because I learned my lesson from the previous video where I used a significantly smaller step over. I used a 10th step over with a flat end mill instead of a ball nose end mill on here. And that gave me this nearly satin, almost burnished sheen to this. And so this is actually ready for probably 320 grit or 400 grit sandpaper, and then it's going to be done. And so that's actually what we're going to be doing next week, is we are going to be gluing it to this neck, and then we're going to sand all the surfaces up and get rid of all the tool marks from last week and get this ready for finish, and then we're going to be installing the frets. So don't miss that video, but until then, I will see you guys. This is Austin, signing out.